So attacks on firewalls. What if an attacker knows that the firewall is going to block their traffic, but the attacker wants to try and get around the firewall? So for example, let's consider a firewall rule that says any connection that sends the word root is disallowed, because maybe the attacker is trying to log in as root, the administrator account, and we want to block that. So anytime the packet filter or the firewall sees the word root, we're going to drop that packet and we'll allow everything else. So we care a lot about stopping attackers from trying to log in as root, and we don't really care about anything else, at least for this example. So if the attacker isn't very clever, they might just start sending packets. So let's be the packet filter and see what the attacker sends. Well, they sent hello world. I don't see the word root, so this is good. We will let it through, and it will reach the server. Login, I don't see any problem with that. I don't see the word root, so we'll let this packet through, and it reaches the server. As root, it has the word root inside, so we're not going to allow this. The firewall is going to drop this packet, and it will not reach the server. So if the attacker wants to log in as root, and they try something like this, it's not going to succeed. One of the packets is going to get dropped. So now start to think like an attacker. If this is what the firewall is doing, what could the attacker do to get around this firewall? Remember, all that it's doing is looking at each packet statelessly, checking for the word root, and dropping if it sees that word. So you can try and brainstorm, pause if you want to, think about what's about to happen. So here's one possible idea for how the attacker can get around this firewall. Remember that TCP messages are split into packets. So if your message is too long, you can split it across multiple packets, and the recipient will reassemble them. So what if, instead of sending the word as login as root in a single packet, which will get dropped, what if we send R, and that reaches the server because the firewall sees R and doesn't see root, and then we send O, the firewall sees that, lets it through, then we send O, the firewall sees that, lets it through, and then we send T, and the firewall sees that and lets that through. All 4 of the packets made it through. When they reach the server is going to reconstruct the original message by putting all of those letters together, and the word root has arrived at the server. So the attacker has gotten around the firewall by splitting the word up across individual packets, and the firewall is not going to notice any of those individual packets. So what if your firewall gets smarter? Maybe your firewall now is keeping track of the letters that you've previously seen. Well, now if the firewall notices that you're spelling R-O-O-T, maybe it will drop those packets. So what could the attacker do? Well, remember that TCP also rearranges packets that are out of order. If you send packets out of order, the recipient will use the sequence numbers to reconstruct them. So maybe instead of sending R-O-O-T, which might cause the firewall to block our packets that are spelling out root, what if we first sent the O packet with sequence number 6, then we sent R with number 4, then we sent O with 5, and T with sequence number 7. So if the firewall is trying to keep track of what it's seen so far and it's not thinking about rearranging packets, it might think that we're trying to send O-rot. Well, that's not root, so the firewall allows it. But once it reaches the destination notices that these are out of order, reassembles them by putting them in sequence number order. And once again, you get R-O-O-T, and the attacker has evaded the firewall. So to stop this, now the firewall has to keep track of the TCP connection and reconstruct the sequence numbers as well. So as the attacker gets more clever, the firewall also has to get more clever to stop these attacks. First, it had to remember how to put packets together. Then it also had to remember or think about reconstructing out-of-order packets in order to stop these attacks.